Well, hello everybody, and today we're going to be talking about chapter 6, which is memory. So, what is memory? And it's a good question. People think about memory in different ways, but it somehow involves a brain process or a number of brain processes that have to encode information, store information, and then allow you to retrieve information. There's no universally accepted model or theory, but there's some general agreement on the processes that happen in the brain. There's a lot of research going on as to how memory actually works in the brain. And again, that general process of encoding, storage, and retrieval seems to be important. We're going to do a few quick memory tests during this lecture, so if you could just be sure you have a piece of paper and a pencil or pen with you. We'll do some little activities, and I just need you to write some things down as we're going through. So go ahead and be sure you have that. All right, so memory. If you look around you, wherever you are right now, your sensory system is processing a lot of information. There's visual information, sound, touch, smell, etc. And so going through this process of encoding, storing, retrieving, encoding is the process through which information enters our memory system. And so we have to transform information from the world into neural activity, and now you know neural activity means an action potential that travels to the brain. And with all the information that's around you at every given moment, there are two possible paths for that information. One is that the information enters your memory system, or we call it encoded, or the information is lost. And this really has a lot to do with what you're paying attention to, where your attention is. You're not going to encode every little detail of the room around you, wherever you are right now. But whatever you're paying attention to or somewhat paying attention to may get encoded, meaning brought into our neural central nervous system, basically. Then we go to storing the information, and this is the process of preserving information so that we can remember it in the future. So how do we maintain or store the encoded information in our memory? And then the last part, very important, particularly as students, when you're taking tests, you need to retrieve the information. So once it's stored, how do you get it back again? How do you access information from the past which has been encoded and stored? And this is what we'll be talking about today. So number one, how deep are your memories? There is this level of processing theory that emphasizes the degree to which new material is mentally analyzed. And the greater the intensity of your initial processing of the information, the more likely you are to remember the information. And you could think of this in terms of shallow processing, intermediate processing, or deep processing. And you're more likely to remember information if you deeply process it as you are learning it, as you are presented the information. So in terms of studying, shallow processing would basically just be like reading briefly over your textbook. Maybe intermediate would have note cards, and you're just flipping through note cards with the answers, flipping through the note cards and looking at the question and the answer. But deep, this is the key. If you can deeply process the information in the beginning, you're more likely to remember it. So this could be thinking about how the information relates to you. And that's what we were trying to do, and I'm trying to do in this class, being that I wrote my dissertation on memory, learning and memory. I'm trying to get you to deeply process the information. So when I asked you a question about nature versus nurture in your elementary school years, it's to help you think about and kind of self-reflect on that concept of nature versus nurture. That's going to be more helpful when you're trying to remember what is nature versus nurture on a test or something like that. Imagery. using an example in class, an in-class example. And again, we're going to do some examples even over the computer to help you understand the concepts versus just passively reading the material. Linking of new information to information you already know, etc. And in fact, I'm going to give you 5 seconds to try to remember these letters. Now write down the letters that I asked you to remember. This is probably hard. However, if I told you to remember the word friend, which are those same letters, wouldn't that be much easier? Well, the reason is those letters are more deeply connected. You can say, oh, I can remember all these letters because they are deeply connected in that word friend. I can remember the word friend, and that makes the whole process much easier. So again, the goal is to more deeply process the information initially, and then it makes it easier to remember later on. All right, so stages of memory, as I said, there are different theories. Nobody has the exact answer, but there are different theories as to how memory works. So we're going to look at the information processing model first of all. And this is that memory flows through different stages, and each stage differs in capacity and duration. So information comes in, and it first becomes what we call a sensory memory. And sensory memories, those are, again, just bringing in information through your visual system, through your auditory system. We call the sight memory iconic, and the sound information echoic, other sensory information. And that is brought in and then typically forgotten within 1 second, unless you do something, you pay attention to the information, you rehearse the information, and if you do that, you can get the information into short-term memory. Short-term memory is typically forgotten within 15 to 25 seconds. It's short-term. But again, if you do more rehearsal, more elaborative rehearsal, more studying, working with the information, you can get information into long-term memory. And long-term memory, we believe, is pretty much forever. So in terms of the stages of memory, as I said, sensory memory is the first stage, and it captures near exact copies of vast amounts of information for a very brief period of time. So again, if you just look around the room or wherever you happen to be, you're bringing in a huge amount of information about everything that you see, and that's all brought into your memory for a very brief amount of time. There's no way you could remember everything wherever you are. I couldn't ask you, tell me how many books are on the bookshelf next to you, or how many, I don't know, drawers are in the kitchen if you're studying in the kitchen. You're just bringing it in, and it pretty much all goes away within a second. And again, as we mentioned, the iconic memory, that's the visual impressions. They're like photographs in their accuracy, but dissolve in less than a second. So again, you're bringing all that information in, but it pretty much disappears. And the echoic memory, exact copies of all the sounds that we hear. They test this in that they show people an array of letters for a very short amount of time, 1/20th of a second, and they're able to show that all that information actually does get into your brain. But then when they tell you, the experimenter says, now tell me how the letters that you saw, people can't remember nearly all of them, right? It is very difficult. An exception to that is eidetic memory, and this is the ability that some people have to see an image or an object long after it's been removed from sight and are able to describe it with amazing detail. This is similar to the concept of photographic memory. You might have heard that term. We see this sometimes in individuals who are diagnosed with autism who have an extreme, what we call savant ability in their memory to be able to see and remember very detailed information, having just seen it for a very brief amount of time. And there are a number of people who do this, but one of them is Stephen Wiltshire, who's pretty famous, called The Human Camera. And I've put a video of his amazing ability on Canvas for you to watch. But again, this is extremely rare. Now, short-term memory. So after the sensory memory stage, some information will make it into your short-term memory. So that's the second stage of memory. It temporarily holds information for a limited amount of time, about 30 seconds. Information must be attended to, meaning you have to pay attention to it in order to get it into short-term memory. So again, if you're just briefly looking around your room and then I say to you, I don't know, how many drawers, how many drawer handles, how many books, although you have seen it, you haven't gotten that into your short-term memory. But information that you are paying attention to will get into the second stage of short-term memory. We say that short-term memory has a capacity of 7 plus or minus 2 chunks of information. This is like a magic number, 7 plus or minus 2, meaning short-term memory can hold about 5 to 9 pieces or chunks of information. That's why, and I guess we don't have to remember phone numbers very much anymore, but when we did, it's easier to remember them in chunks, like the first 3 numbers, the second 3 numbers as a chunk, and the last 4 numbers. Instead of trying to remember every number separately, we would try to kind of put them together. And we're going to do a little experiment on this in a second. So 7 plus or minus 2 chunks of information is kind of the capacity of short-term memory. Once information in short-term memory is lost, it's lost forever. You cannot get it back. It's just there and then it's gone. You can extend the duration of short-term memory with what we call maintenance rehearsal, which is repeating the information over and over and over again. So, as we said, the capacity of short-term memory is this magic 7 plus or minus 2. And we test this very often as neuropsychologists using something called the digit span test. And so we're going to practice this right now. You actually don't need a piece of paper for this. If you're alone in wherever you are, all I'm going to do is say some numbers, and then I just want you to repeat them right after me. So if I said 5, 2, then you would say 5, 2. Okay? So here we go. 6, 9, 4. Hopefully you said 6, 9, 4. Okay. 7, 2, 8, 6. 4, 2, 7, 3, 1. 6, 1, 2, 4, 8, 7. 5, 9, 1, 9, 3, 8, 6. 5, 8, 1, 9, 5, 6, 4, 7. 7, 1, 3, 9, 4, 2, 5, 6, 8. So you probably noticed this got harder and harder as the string of digits got longer and longer. And that's because we are just getting this information briefly into your short-term memory, and you have a limited capacity. As there were more and more numbers, it became harder and harder to do. And as we said, if the information is lost, it's gone forever. If I asked you, hey, could you tell me that second to last number? You couldn't do it. It's gone because you haven't been rehearsing it. You hadn't been practicing it. Let's try this one also. Get out a piece of paper, that if you would, just your pencil. I'm going to show you some words and I want you to try to remember them. Don't write them down on the piece of paper when you're looking at them. I just want you to look at the words and then I'll take them off and I'm going to ask you to write them down. Okay, so no cheating. I know we're not even in class. This is just an example. So here we go. So just look at these words and try to remember them. All right, now try to write them down. If you need more time, you could pause this, but I'm going to go on to the next one. Now I have some other letters for you to remember. I want you to try to remember them. Don't write them down until I take them away. Here we go. Okay, now try to write them down. Again, you can pause this if you need more time. But if I were to ask you which one was harder, probably this one. Even though it was the same number of letters, these are broken into words, or we would call chunks of meaningful information, right? Hot, city, book. So you're actually only remembering 1, 2, 3, 4, 5, 6 chunks of information. However, these words these letters are not really broken up into anything that makes any sense. So you're having to remember many more individual pieces of information, and it is much harder. So even though it's the same amount of letters, it's that idea of chunking that information into meaningful groups that then makes it easier to remember more information. All right, stages of working memory. So this is kind of an update to the information processing model that we talked about: sensory memory, short-term memory, and we're going to get to long-term memory in a second. But Badley had this update of what's going on in short-term information, and he called this working memory. That's what is going on or happening in short-term memory, and that there are 4 components of this working memory, and the goal here is to maintain or manipulate or work with the information in your short-term memory. And so number 1, called this the central executive, that directs your attention to whatever information you need to process. Do I need to process something I'm looking at? Do I need to process something I heard? So the central executive directs your attention. 2, what's either called the visuospatial sketch pad. This is the part of your brain that is working with visual or spatial information. I need to go to the grocery store. What do we need? Let me think about where things are in the store to see what I can think about that I need to get at the store. The phonological loop. This is another component of working memory that works with verbal information. What do we need? And someone told me, my roommate told me we need butter, egg, salsa, but was it milk? And you're kind of working with that verbal or that auditory information. That happens in the phonological loop. And then the episodic buffer. This is bringing information together to allow us to solve problems. Do we need milk? And it's going to kind of bring everything together to let us solve the problem that we're dealing with. So how then do we get information from short-term memory to long-term memory? The key here is rehearsal. And as I said, I wrote my dissertation on memory, and there is no shortcut to memory. The only thing you can do is rehearse and practice. The more you do, the better information gets into long-term memory, and the deeper your rehearsal and your practice, the better. So, if you just do repetitive rehearsal, it really keeps information in short-term memory. That's like memorizing a phone number and you just keep saying it again and again in your head. Well, eventually whatever you get, you write it down or you put it in your cell phone and then it's gone. But what you want to do is elaborative rehearsal. This is the kind of rehearsal that moves information to your long-term memory. This is when you think about the information in some way, you consider it, you try to make it make sense with your own experience, you do something to make it meaningful or organize it in some way. And long-term memory is a stage of memory with essentially unlimited capacity, so not that 7 plus or minus 2 chunks. You can remember pretty much everything. And stores information indefinitely. There doesn't seem to be an end to that. And long-term memory is broken up, you can see, into a number of different types of long-term memory. We have explicit memories. Those are memories you're aware of, things you can talk about, basically. And implicit memories are memories that really you're not aware of. You just know them kind of unconsciously or subconsciously, like riding a bike. You know how to ride it if you've ever learned. You know how to ride a bike. You couldn't really tell me what it is that you do to exactly ride a bike, but your body just knows how to do it. That's an implicit memory. You're not exactly aware of it, and even if you hadn't ridden a bike in many years and then you get back on a bike, you just know how to do it. Whereas explicit memories are memories we talk about. Or we can talk about. And let's break explicit memories into two categories of semantic memories. These are general facts. I really like how this is broken up here for you in this chart. I do have the words here as well. So semantic memory, general facts. If you can say, I know who the President of the United States is. I know what the capital of California is. Things you know. Those are semantic memories. And episodic memories are your personal experience, memories of episodes. And typically you say, I remember. These are information about events. I remember my first day of school. I remember my wedding day. I remember those kinds of things. Those we call episodic memories. And then implicit memories, procedural, how to perform actions. That's like how to ride a bike, how to drive a car. You remember when you're learning how to ride a bike, it takes a while to learn, to figure it out, for your body to understand how to do it all. And then once you get it, again, it's just implicit. You just know how. And there are other types of implicit memories like priming we're not going to get into right now. And the reason this is so important is that we see with certain types of brain damage, for instance, there are people who, and we'll talk about this, lose their explicit memories, but keep their implicit memories ability. So we know that these different types of long-term memories are housed somewhere different in the brain. All right. There's also something called flashbulb memories, and these are very detailed accounts of circumstances that surround an emotionally significant, shocking, maybe historic event, something so vivid, it's as if you took a picture of that moment. And what we see is that meaningful emotional experiences seem to enhance memory consolidation. And memory consolidation is the moving of information from short-term memory to long-term memory. We call that move from short-term to long-term the consolidation of memory. And so you can think back to your own life. Many people have flashbulb memories of exactly where they were on 9/11. I certainly do. I can remember it as if somebody videotaped it, and I could watch it back. Other meaningful events, things like you might remember your prom, what you wore to prom, much better than if I asked you, what did you wear, the fourth day of your junior year of high school, right? Probably won't remember that. So emotional events, birthday parties, weddings, different things, and it can be good experiences, it could be stressful, bad, negative experiences. We remember them much more clearly than kind of the rest of our memories. And it seems that there's an increase of what we call cortisol and epinephrine. These are our stress hormones that activate an area of the brain called the amygdala that's responsible for emotion. And it's that cortisol and epinephrine that really seems to enhance the storage and consolidation of memories. And in fact, we see that there's been research studies where they have people come to a research lab and they actually just inject cortisol or epinephrine. So nothing exciting or stressful is actually happening, but they just get an injection while they're trying to remember very boring, bland information, and they remember it much more, much better. But we also know that prolonged stress results in more cortisol release and memory actually is impaired. So too much cortisol for too long a period of time is not helpful. And again, this cortisol and epinephrine activate a part of the brain called the amygdala, important for emotion. And when people have damage to the amygdala, they don't remember, they don't experience this like we do, people do when their amygdala is working. And in fact, they do research studies where they say a list of words, some very typical words and some taboo words. It could be a bad word or something like that. And typically people remember the curse words and things like that better. They kind of are shocked by that. Again, you get that release of like, ooh, stress and that cortisol, and those words people remember better. People with damage to the amygdala don't remember those taboo words better. They'd just be as likely to remember the word chair as something else. And so you could think about what flashbulb memories you have in your life. The best way to make memories, again, more deeply processing information using mnemonics. This is all different things. You can words that sound alike, come up with rhymes, using the first letters of words. Maybe you might have used this Roy G. Biv to remember the color of the rainbow. Anything to help you remember. Come up with a song, come up with a poem. Again, put in effort. Be conscious and aware that you're trying to remember the information. Just simply flipping through flashcards as you're, watching TV or listening to music is not going to get that information into a deep long-term memory that will be easy to access. Elaborative rehearsal, and this is what I said, connecting information to other information that's already in your long-term memory. Things about your life, ways that you can remember it personally to you. Spacing is key, the idea of distributive practice, spreading out study sessions over time with breaks in between. Cramming everything all in one night has been shown not to be as effective as spreading out your study sessions over time. How about retrieving information and forgetting information? So when we talk about retrieving or getting information back, again, remember, think about studying for a test and then needing to retrieve that information. There are two ways we retrieve information. One is recall or free recall. This is the process of retrieving information held in long-term memory without the help of any retrieval cues. So this would be like a short answer or an essay question where they just say, tell me everything you know about memory, and it's a blank, and you have to answer it. Versus recognition, retrieval with recognition. Recognition is the process of matching incoming data to data stored in long-term memory. Recognition would be like multiple choice. These are which one is not a part of the memory system, and you have 4 choices, and you have to circle the one that's not a choice. Which of these two processes is generally easier? Typically, recognition. Free recall, you're just trying to kind of get it out of nowhere. And recognition often helps kind of jog your memory. You have a cue and you can often remember more information. So let's try it with your piece of paper. Without looking it up, again, no cheating, write down the names of the 7 dwarfs from Snow White and the 7 Dwarfs. Of course, you'd have to have watched that movie at some point to know. Pause if you need more time, and then start up again. Now here, this would try to figure out which ones of these are the names of the 7 dwarfs. And again, I'll let you pause this if you need more time. Then you can look up the answer to see if you're right. But this would be recall, free recall, just asking you to name the names of the 7 dwarfs without any help, without any cues. And here's recognition. You're recognizing. Oh, let's see. Is Goofy one? Is Sleepy one? Is Meanie? I know it's not Meanie, right? And you probably got more correct using recognition memory. All right, retrieval and forgetting. We also have learned about the serial position effect, which is when you have a list of information, depending on where the items are in the list, depends on how well you remember them. We have what we call the primacy and recency effect. In the primacy effect, people tend to remember the first items, the items in the beginning of the list, and the recency effect, people tend to remember items better at the end of a list. It's the middle of the list that often gets lost. So if you're a server in a restaurant and a group of 10 is seated in your section, whose orders are you most likely to forget? Everybody in the middle, right? You might remember person 1 and person 2 and person 9 and person 10, and those middle ones are harder to remember. How does your environment impact your ability to retrieve memories? This is the encoding specificity principle, that memories are more easily recalled when the context and cues at the time of encoding or of learning are similar to those at the time of retrieval. So context-dependent memories are easy to access when encoded and retrieved in the same context. State-dependent memory is remembering things is also easier when the physiological and psychological conditions, including your mood and emotions, are similar at the time of encoding and retrieval. Retrieval is easier when the content of a memory corresponds to our present emotional state. These are things we've learned from real detailed memory studies. Not to say you can't remember something if your mood is one way when you're studying it and another way when you're remembering it, but we do see that it's easier for people to bring back those memories in terms of kind of context being similar. Hermann Ebbinghaus, the famous memory researcher, he used a single subject design, and he quantified how we learned information and relearned information, and also how we forgot information or forget information. And he established this forgetting curve, where immediately after learning, you know 100% of the material, and how very quickly we lose information that we've learned, right? At an hour, you're over here, less than 50%. But then once that curve flattens out, whatever you remember, even if it's 15% of it, stays with you for a very long time. Also, you will forget information if you've never encoded it in the first place. So sometimes we think we know things, but we never really spent the time to encode, and so of course we can never remember or retrieve that information. For example, you could look at these logos, and are any of these the right Apple logo? You might say, well, I've seen the Apple logo 100 times, and please, if you have an Apple that you're using right now, that's going to mess this one up. But I don't know which is right or wrong here, because I know I've seen it, but I've never spent the time to encode that information into my memory. So sometimes that is a reason that we can't retrieve the information. Retrieval can also be influenced or blocked by information we learn before or after. We call this interference. And there's two types, proactive and retroactive interference. So you can see here, proactive interference is when old information interferes with newly learned information. So pro, kind of before, okay? So if you learned Spanish originally, and then you learned Italian, you have to take an Italian test, and you don't do well on the Italian test, it could be that your learning of Spanish proactively interfered with your learning of Italian, and you didn't quite learn the Italian. You keep making mistakes because of this, that you had learned Spanish prior. Retroactive interference is when information learned after interferes with prior information. So if you learned Spanish first, and then you learned Italian, and then you take a Spanish test, well, your learning of Italian can retroactively interfere with your learning of Spanish, and you don't do as well on your Spanish test. What if we couldn't forget? There is a theory that we have to forget, that if you think about it, we forget most of what we've experienced. We forget the details of the majority of our life. And there was a theory that we had to do that, or our brain would get cluttered and we wouldn't be able to think. It would just be too much, that we have to forget information that isn't important. However, there are people who don't seem to forget anything, people with what's called highly superior autobiographical memory. They retain almost everything in their memory, and their minds are not cluttered. I have an extremely interesting video. This was on 60 Minutes. It's 2 parts, and I really suggest you watch it. It is a very interesting story about these people with these highly superior autobiographical memories. So please watch that. In terms of reliability of memory, this is the idea of the Reconstructionist view of memory, that memories are a creative, I like this, blending of fact and fiction. Even though we believe our memories to be totally factual, it is not only our memory of what happened, but our memories incorporate our own perspective, our own personal experiences. That all goes into the creative of our memories. Sometimes we unknowingly edit our memories, incorporating bits and pieces of information we learned after the fact. Memories are influenced by the meaning that we give to events. Even where you're standing, if you think about eyewitness accounts, and eyewitness accounts of crimes are actually pretty notoriously poor. But something as simple as where you were standing might totally change how you saw an event. If you're looking at the person in the light, or is the sun in your eyes, can you tell the color of the shirt? Can you Were you scared? Where were you looking? All of that goes into your memory. And so while we like to believe our memories are purely fact, they're actually a little bit of a blending of what we actually experienced and some creativity in our own subconscious that has created our memory. In terms of the biology of memory, we study amnesia, which is memory loss, and that can help us understand the biological basis of memory. Amnesia can have a physical cause, some kind of brain damage, or psychological cause. We see amnesia due to severe trauma and things like that. Amnesia varies by type, the kind of impairment, and by the degree. You can have mild amnesia to very severe amnesia. Two different main types. So here we are now. Anterograde amnesia. So let's say now this person has a head injury. They're in a car accident. If someone had anterograde amnesia, they are not able to make any new memories. They can't create any new memories after the car accident. They remember their past life. They remember, I don't know, their family members, what their job was. They remember all that. But after the accident, they cannot create any new memories. And we're going to talk about this with a patient in a second, patient HM, who had severe anterograde amnesia. Retrograde amnesia is here's the car accident, and they lose any memory of things that happened before the car accident. Okay, that's a retrograde. They don't remember who their parents are, who the type of job they had, things like that. And global amnesia would be amnesia for everything. The brain structure that's really implicated in memory is called the hippocampus. The hippocampus is here in the temporal lobe. And it seems to be very important in consolidating, there's that word again, short-term memory to long-term memory, changing short-term to long-term memory. Okay, particularly for explicit memories, those memories you can talk about. But a researcher named Lashley discovered that memory really is all over the brain, and he talked about what he called the engram. That's the memory trace is distributed all throughout the brain. So having damage to one little part of your brain is not going to wipe out all your memories. Probably the most famous case study in terms of memory was in the biology of memory is patient HM. He had very severe epilepsy that they couldn't treat, and so he underwent a surgery to remove parts of his brain, including the hippocampus, and they removed the hippocampus in both the left and right hemispheres. And what happened after that surgery was he had profound anterograde amnesia. He could not remember, I'm finding this, anterograde amnesia, could not create any new memories. He couldn't move anything from short-term to long-term memories. And we said the hippocampus is important in consolidating short-term to long-term memories. How do we know that? Very much from patient HM. He had a little bit of retrograde amnesia, but it was really the profound anterograde amnesia that was so striking. And he also maintained his ability to learn new implicit memories, new procedural memories. So I'm going to go on and explain this to you in a little more detail. So he had bilateral removal of his medial temporal lobes, which included the hippocampus. And he had, like I said, this massive anterograde amnesia after the surgery. He could not form any new memories after the damage occurred. He couldn't remember any events after the operation, and he lived for decades after this operation. He couldn't learn his way to the bathroom in the hospital. He would tell someone a story, maybe, then turn around, look back at that person, and tell them the same story. Couldn't remember he had done that. A doctor would come into the hospital, the doctor would introduce themselves, and then leave, and the doctor could come back a minute later and he would need to reintroduce himself. The HM did not remember who this person was. And this was a problem throughout his entire life. He had moderate retrograde amnesia for events 1 to 3 years before the operation, but not as severe and striking. So again, he had a declarative, or we would call it an explicit or a declarative memory deficit, that he couldn't state memory in words. He couldn't come up with any new facts, learn any new facts or information after the surgery. So he couldn't learn who is the president now, where do you live now if they move. They wouldn't remember his new address. But his procedural memory was intact, meaning he could develop new motor skills. And they were able to show this by teaching him new skills. For instance, reading words written backwards like this, which is very hard to do. But with practice, people get better at it. And so a researcher would come to the lab, work on this backward word reading with him, time him maybe on a specific test, leave. The next day, he wouldn't remember that he had done this before. He'd say, oh, this is new to me. I've never done it. And again, practice and get tested over and over. He would never remember having learned this skill, but he got better at it, meaning you could read these words much quicker with less errors as time went on. So he definitely still had this implicit ability in his memory, even though he wouldn't remember doing it. And same with drawing something seen in a mirror. They did this mirror drawing. That's also very hard. If you're trying to draw something while looking at a mirror, everything is backwards and flipped around. He wouldn't remember that he was being taught this many times for many days or weeks, but his ability to do it got better and better over time. Surgical patients who had a similar surgery but an intact hippocampus, meaning they did not take out the hippocampus, showed no memory impairment. So this is really how we learned that the hippocampus was such an important, plays such an important role in consolidating explicit memory. In terms of the biology of memory as well, there's research on what's called long-term potentiation. Long-term potentiation seems to be what happens in the brain at the neuron level to allow us to remember things. Again, all of our memories have to reside somewhere in our neurons, in our brains. And we see that you get this increased efficiency of communication at the synapse after learning has occurred. And again, we're in the very basic stages of understanding learning, but this does appear to be part of what we see, this long-term potentiation. And you can even see it in a sea slug when you look at the neurons there and you see this increased efficiency of neural communication. Alzheimer's disease, this is a disease mostly of memory. It's a progressive brain illness. It causes all sorts of cognitive decline, including memory, language, and thinking problems. In the brain, you see what we call neurofibrillary tangles and amyloid plaques. Those are the hallmark features of what we see in brains of individuals with Alzheimer's. Now, unfortunately, those are pretty hard to see in any kind of a scan. Typically, we can only get a definitive diagnosis of Alzheimer's disease post-mortem, but we know the typical cognitive and memory problems that we see in individuals with Alzheimer's, and so we often make the diagnosis when we see that typical pattern. What causes Alzheimer's disease? Again, we don't know for sure. Genetics play a role, and lifestyle factors like diet and exercise. And how do we keep our memory for as long as we can? You can take a look at this in your book as well. Family, there's maybe some genes. Exercise seems to be important for keeping your memory, intellectual stimulation, and social activity, all really good things. And lastly, chronic traumatic encephalopathy, CTE. I've heard about this. It's gotten more information or more discussion in the news. This is a neurodegenerative disease that leads to deposits of what we call a tau protein in the brain. And this is a result of repeated mild traumatic brain injury. We talk about this in sports now and football players and things like that. Symptoms are memory issues, impulsivity, aggression, insomnia, problems with speech, and depression. And you can see these symptoms months or years after the initial impact. Again, can only be diagnosed post-mortem, and there are all sorts of implications. The more we learn about this, the more there are implications for sports in general, but youth sports and how to protect children as best we can. And you can see that the tau protein starts to accumulate in little local areas. You might get headaches or focusing difficulties. Then it spreads to surrounding areas, and this is a cross-section of the brain. You can see that's a very healthy brain, minus these little tau proteins, but the damage continues to spread. This is when you might have memory loss, planning problems, mood and attention problems, and then widespread damage throughout the brain. So this really is a significant degenerative brain disorder that we're learning more about. All right, thank you all very much.